I think now we have started we have started recording our session. Thank you very much, Virus. So we'll start once again on what circuit simulation is all about. So it's a process in which a model of an electronic circuit is created and analyzed using various software algorithms which predict and verify the behavior and performance of the circuit. So in this case, you are just mimicking of what the final product or a device is going to behave like. So with the thoughts you have in mind, you are able to have a digital simulation in a software to check the response of the circuit that you're about to design. So that is all about circuit simulation. And it is faster and more cost effective to verify the behavior and performance of the circuit using a circuit simulator before fabrication, because you can't be blowing up capacitors, ICs, because you want to simulate on a breadboard or prototyping board to check the response, check the response of the ICs that you are putting in your circuit. But this is a cost-effective way because this process is done in a software, so you can't destroy anything, you can't harm yourself. So it's a very safer way to verify your circuits. Now, let us take a look at types of circuit simulation. So we have three types of circuit simulation. The first one we have got analog circuit simulation, second, digital circuit simulation, and mixed mode circuit simulation. Now, let us take a look on how, what is analog circuit simulation. So it involves the use of highly accurate models, that is representations of the electronic circuit to achieve high accuracy. So in all these things, what it's trying to say is you are putting semiconductors. If you know know semiconductors, they are resistors, diodes. So those components, they don't have discrete characteristics. They don't produce zeros and ones. They just produce a value, the analog values. So you want to get accurate results as far as possible. So you can simulate in a software to get to know the values a specific semiconductor is producing. So it employs algorithms to mathematically analyze the behavior of electronic circuit in in AC, DC, or transient. So as we go along, we'll learn what AC frequency domain is all about, nonlinear quiescent is all about, and time domain is all about. So they are very simple things to grasp. AC, you know, AC power, you know, DC power, and transient, they are used in charging circuits. So it's very simple. These ways shouldn't intimidate you. They are very simple to understand. So let us take a look about digital circuit simulation. So digital circuit simulation, it involves the use of simpler modules of the electronic circuit. So why are we saying that this is simpler? Because digital circuits involves discrete values, zeros and ones. So you just switch it to 0 and 1. So it's not as hard as coming up with analog circuit simulation, because analog circuit simulation, you want to have as high accurate values as possible. So in this case, we're only focusing on zeros and ones. So they are created by HDL. HDL is hardware description language. So I can give you an example for on where you can utilize digital circuit simulations and where it is utilized. One of the examples is in the computer processors. So in computer processors, I think if you follow on the digital and technology trends, There is a new processor from Intel, the 13th gen. The 13th gen has got almost 8+ billion transistors in a single chip that you can carry in your hand. But how do they fix more than 8 billion transistors in a chip that you can carry in your hand? So they use digital simulation and they fabricate them, because we are going to go into PCB design. They fabricate them easier because they have simulated them in a software, because the HDL is just programming, and that program you have wrote, it will produce a hardware device that you can use in your system. So HDLs, they are used in digital circuit simulation, and it allows much larger circuits to be simulated in less time with fewer compute resources when compared to analog simulation. As I already said, these much larger circuits are found in computers. In your phone, you understand that in your phone, the processor is very small, but it's able to do, it's able to compute a lot of programs, but with a smaller chip. So these simulations are mostly found with digital circuits. Now, let us go to the last type of circuit simulation, mixed mode circuit simulation. So in this case, you combine the two, the analog and the digital simulation. So what mixed mode circuit simulation is all about is you have a system which consists of analog circuits and digital circuits. You combine them together, and to check, you will check if the system is able to respond in the way you intended to do. So most of components right now in the world, they use the combination of two to get the values the engineers are intended to have. So let us take a look about benefits of circuit simulation. So the first one, it provides critical view into the behavior of the electronic circuit. So you are able to check how your circuit is behaving, is responding to the results that you are intending to have. So most especially if you are creating high critical devices, for example, in hospitals, you want to create a device which is able to produce a certain charge to a patient. You can't prototype it on the patient, him or herself. You have to prototype it in the software to check if the software, if the device is able to respond to the signals you intend. So it's very important and safe to use circuit simulation. The second one is more practical to validate circuit behavior and performance via circuit simulation prior to manufacturing. So what this benefit is telling you is that it's more costly, and you can have it is easier to validate a circuit in simulation rather than you manufacture it and you start to validate it. If something breaks, you have to start the whole process again. So this way, it's very more practical and easier to validate your circuit. So some of the areas of validation, these are just examples. You can use, you can find more areas of validating in your circuits, because I believe that after this training, you try to come up with your circuit you come up with your circuit to produce a certain device. So some of the areas of validation, we have memory performance, because memory performance, you want to check the speed of reads and write in your circuit. So you get generate a memory module, then test the speed and the accuracy of your device. So you simulate in the simulation software to check the speed of reads and write on your memory module. The second one is overall digital simulation accuracy. So in this case, you are able to check the accuracy of digital circuits. So if the ICs are able to produce the desired results, if they're able to trigger by a certain input, you are able to test that, because digital modules, digital ICs are very sensitive. they can break, or maybe they will not produce the required result. So you are able to simulate that and you check with the physical module if they are producing the desired results you wanted. Another part is noise and crosstalk. Most especially people who are in telecommunication, they know what noise and crosstalk is all about. So in simulation, this is one of the major areas that you focus in, the crosstalk and noise. You want to reduce noise as much as possible. I believe everyone here has got a phone. If you have a modern phone, maybe phone in 2022, that's good. But some of us were using phones maybe in 2018, from 2018, 2017. These phones, they tend to get hot when you are using them on internet for a long time. So the thing in which tends to heat up your phone, it is none other than noise. So the noise from the network, it's able to increase the high temperatures of your phone. Or if you are playing a game, you understand that the back of the phone that you are using, it will get hotter because of the noise of the ICs inside your phone. But those people who are using phones from 2021 to 2022, you understand that one of the things that these phones they are emphasizing is that the phones are getting cooler and cooler. They have a technology. They will try to do marketing stunts. They have a technology to cool the phone. No, what they're trying to do is to reduce the noise and the crosstalk, so that you should have phones that they will not get hot easier as you are using them. The last area of validation that I want to present to you is optimization of high frequency and high power circuits. This point speaks for itself. You can't play around with higher circuits when you are prototyping. Anyhow, high frequency circuits, you can't play around with them. You are going to get hurt, even lose your life. So the safer way of simulating this software is by the means of it's by the means of simulating them in the simulation softwares. So you check to get the optimal result you are looking for. Now let us take a look at simulation softwares that are there in the world, and the most popular simulation softwares. I believe my picture says EDA. So EDA is also they are used in PCB designing. So we use one of the softwares in here to simulate and also to design our circuit. So we have EDA, the software which we're going to use in this entry course. We have Matism, we have got Circuit Maker, we have got Ego, Proteus, KiCad. So these softwares are the ones that are available on the market to use for in circuit simulation. So we are going to use EDA because it has got a free version which we can do a little bit of simulation and PCB designing. So let us go into PCB designing. If you have any questions, you ask them in the last section. So let us go to PCB designing. Now we have simulated the circuit. We have seen how we can come up with a simulation of an analog circuit or a digital circuit. Now we want to fabricate that circuit that we want to come up with into production. So we will go into PCB designing so that we can have our product in hand. Now, what is PCB designing? So it is an act of bringing your electronic circuits to life in the physical form. The simulation or the circuit that you are thinking of, now you will bring that into the physical form, something that is very tangible. So in PCB designing, I already said we use PCBs. So PCBs are printed circuit board. It's made of thin substrate board embedded with electronic components interconnected using thin layer of copper and interconnecting traces. So this definition shouldn't intimidate you. They're just saying it's a board that you place components and connect them. and connect them in their interconnecting traces. So you build traces and whatsoever. So let us take a look at importance of PCB designing. I believe some of you here, you are engineers, or some of you are thinking of coming up with a device. So we will see the importance of PCB designing that you can grasp in your area of study or the projects that you are about to conduct. So the first one is compact design. If you design your circuits on a breadboard, or connecting traces of wires, it's going to be very complex. And if you are designing complex devices, it's going to be very hard to maneuver in your product. So PCBs, they bring compact design. You can have more traces in a single, in maybe a smaller board that you have designed. So, and also it has good, it enhance ease of testing and repair. So you are able to test your device in an easier way, and you're able to repair. I think if you have ever went to a technician, a phone technician, they're able to solder and desolder the components because it's easier to do so with a PCB. And also it has got lower assembly errors because during PCB designing, you do validation, you do design rules, so you validate the points if they are connected in the proper manner. And also you avoid short circuits. This explains for itself. So if you have wires hanging around, you can have short circuits. You don't want that in your device. So another area, it reduces noise and interference. So I already said that noise and crosstalk is a major problem in most devices nowadays. But with the PCBs, you will reduce the noise and the interference. One last thing, which is more important, is improved repeatability and reliability. Since you have to create only a single design, and you can manufacture millions of devices at once with a single design, just like Apple, Microsoft, Intel, that's how they do it. They design one PCB design, and they just place they will just press a button to fabricate millions of them. So only a one-time job, you're able to earn more profits along the way without doing the work. So examples of PCB designing softwares, we have EasyEDA, we have OTM Designer, Ego, SolidWorks, KiCad, and Proteus. So to the right, you find the logos of these softwares. So we are going to use EasyEDA in this course. It's very easy to maneuver. Once you know one PCB designing software, it's going to be very easy to know all of them. Now, let us take a look at processes, a PCB designing process that are there that will undergo through in this course. So the first one is understanding electrical parameters. So you understand, you need to come up with the needs that you want. For example, current maximums, voltages, signal types, the components, or where you are going to put the components. So this is like identify the problem, like a problem statement. So you actually combine the needs that you want your device to have, or the response of your device. The second step is to create the schematic. So in this case, you're going to use the software to create the schematic design. So the softwares, they already have good symbols that depict maybe ground, VCCs, or resistors. So we are going to use those symbols that are already there in the software to come up with our schematic design of the PCB we are trying to produce. The third step is use a schematic capture tool to create the PCB layout. Now, what is a schematic capture tool? So a schematic capture tool is just a tool of converting a paper design into electrical representation. So whatever you have designed on your paper, you use the schematic capture tool to align those components in the way you intended them to be. Another area is design your PCB stack up. So this is not a required way, I would say so. So if you are doing simple PCBs, you don't have to do this, but what they're trying to say is refers to how much and how quickly electricity can travel down the tray. So it's about proximity, and if you are doing 2 layers above PCBs, you are going to refer to this so much rather than if you are doing a single layer PCB. We will see that when we are going into practicals. The fourth step is about define design rules. So the PCB softwares give us a feature that we define our rules, the rules that we want, our the width of our traces. So if you define these rules, when you make a mistake in your designing of the components or arranging of the components, the system the system automatically informs you if you make a mistake. So you are able to correct those mistakes before you save the project. And step 6 is placing your components. This is a fun and easier way, step in PCB designing process, because you arrange the components in a beautiful way, in an elegant way, and also you follow some standards when placing the components in your PCB design. So this 7th step is insert drill holes. So I think I can give example that if you have a PCB that it has got through hole components, maybe resistors, you insert the drill holes are already inserted manually in the on the board, so you don't have to do anything else. So this step it's done manually. The 8th step is route the traces. So you connect the traces in the way that you want them to look in the final board. The 9th step and the last step, the 10th step, is to add labels. A good PCB designer will add labels so that they will be able to identify any change, identify where to place the components when they are soldering them on the board. The last step is to generate the design layout. So in this case, we just generate the files that will be ready for fabrication. So let us take a look on PCB fabrication, the types of boards that are there. The first one is the milling circuit board, the one on the top. So that one you mill using CNC machines. The second one is perforated boards. So these are already sold on the market, but they don't look very professional. But they are there, a simple way of coming up with a PCB. The last one is the professional PCB fab. So these are the PCB boards that will focus on this course, how to generate these PCBs. So the software that we use in this course is IdealabMw. I've already sent the link in the resource channel in PCB Designing and Simulation community. So you find the link in the channel to download IdealabMw. Once you download it, open it and create an account for IdealabMw, then off you go to design. So at this juncture, I'll open the floor to questions. If you have any questions, this is the moment that you should ask. I will only entertain 3 questions. If you have further questions, please use the Discord channel to ask further questions. Any questions so far? You can also use the meeting chat. We have a question from Lucky. Can you explain brief summary, because I found you while you started already. So this training focused on simulation and the PCB design. So in simulation, you are able, what you are trying to do is to simulate the, let me say, the overall circuit of the device that you are trying to produce. It may be maybe an inverter. So you're trying to see what response the device is able to give you in relation to the inputs that you have placed in your circuit. So you're able to see that and you're able to collect that and you're able to choose the right components that are suitable for your device. So on PCB designing, we are trying to now to get the overall circuit and print the PCB boards that will easily replace the components that we have, the components that we have selected for our device. So you just create the board and you buy the components. So it's easier, you just press and solder, off you go. And some other PCB fabrication industries, they will place the components for you. I think for a little charge, maybe $5, they will place the components for you. So that is all about what we have discussed during this session. I hope I have briefly answered you, but that's a very good question. Any questions so far? Have you ever used a breadboard in kind of simulating the whole layout? Can you graduate from breadboarding to this design as in printing a PCB from a breadboard layout? So obviously I have simulated from breadboard. Yes, that's my area. I am a computer engineer, so I have to do that. But however, as the circuit becomes more complex, it's very difficult to simulate on a breadboard. So it's a good practice to learn how to simulate the circuits in these softwares, because it's going to ease your time and you're able to collect lots of things, because you can have a complex circuit on your breadboard, but if you can be my witness that if a wire is disconnected and you are not aware, it's very difficult to troubleshoot. But in this case, these softwares, they're able to tell you that you haven't connected to this wire. So I would refer that you start with digital simulations, then you can go to physical prototyping, which is on the breadboard, when you want to present to your lecturers or to your supervisors. So I think it's a good way to do this. And yes, you can print from a breadboard layout, but you have to design it from the PCB designing software. So you can take the same thing, the way you have connected on a breadboard, and put it in the simulation software to get the results that you intended to do, and making it look compact and beautiful as well. So I don't know if I answered your question, but thanks for the question. Anyone with the last question? Thank you, Virus. All right, I think there are no further questions. I know you have lots of questions, but maybe you are trying to formulate them, but there's still an open door. You can ask them in the in Discord. I reply as fast as possible to your questions. You use Discord and I'll reply you as fast as possible. So anyway, next week, this course is going to run on Wednesdays, starting from 3 p.m. Yes, I'm going to upload this video on YouTube. You said CNC. CNC is a machine that you can use. It's computer, like it's I don't know how I can explain it, but it's a general purpose machine you can use to make traces on copper boards and also design wooden materials. So I'll send the picture of a CNC on Discord. You can check it out. But we use one of the features of CNC whereby you can mill the PCB boards. So yeah, that's what a CNC does. But I'll send a link to what a CNC looks like in Discord. So are there any resources that we can read from this? I'll also send links to resources in the Discord channel. So yes, asking, it's like a printer. Yeah, I don't know if I can say like a printer, but yeah, it prints on the board, not with ink, but it drills traces. So anyway, let us meet each other next week on Wednesdays during this time. If you have any questions, please go to Discord and ask the questions. Next week, we are going to go practical. So make sure you download the software for this course, which is Easy EDA. Create an account, download the desktop grant, and I will see you next week. Thank you for being a wonderful audience and have a good day.